I was just telling someone it seems like you guys have had a lot of homework this week. Like just generally, it's been a big week.
In the shower, I was actually thinking about that. And I was thinking about the Greatest Showman profit and how much they would have made if they didn't hire Zendaya or Zac Efron. I was like, oh my gosh, I should come with Zendaya conversation.
That's so good. That's exactly it. You just become more math minded. You're in it every day, and you start thinking more about the math. Alright, any calculators? This is a decimal problem. These are real numbers about nuclear energy produced. This is in your book. If you want to see it closer up, it's on page 232. It's in 3.4. It's like number 62 or something. It's 236. 236. If you want to see this problem in your no, sure. That's not what I meant. On here, this problem is solved just like the juggling problem yesterday. So if you want to look at an example, look at the example on page 236. You're going to need to use the quadratic formula. Okay? It's a quadratic formula question. So the amount A of nuclear energy in billions of kilowatt hours generated in the United States is modeled by this quadratic, where T represents the number of years since 1980. I don't know when the first nuclear power plant went up, but maybe it's been the same number since 1980. I don't know. In what year did the amount of nuclear energy generated reach 800 billion kilowatt hours? So, you know, our homes here in Florida, we use about 1,000 kilowatts a day to 2,000 kilowatts a day, depending on the amount, the size of your house. Is it a lot? It's kind of a generalization, you know. Is it a lot compared to someone who doesn't run AC all day? Probably, you know. So, is it more than developing countries? Probably, because we plug everything in. I think it's probably the most out of everybody. So maybe it is a lot. I think Americans use a lot of energy. We're very comfortable. Anyway, what? So 800 billion kilowatt hours. If you think about the whole nation, and we're using 1,000 every day, yeah, that seems like a number we've probably reached already. So A is the amount generated. So it says when. The question's asking when. So it's wanting you to find T. It's wanting you to find time. It says in what year. So they're saying, what is the T value? What year did this happen? And they're given 800 is what you're looking for. So we're going to take the capital A out and you put 800 in. Okay. So I told you already, this is supposed to be practicing the quadratic formula. Well, to do the quadratic formula, you need a 0 here. So make it equal 0. I'm going to set this up for you, and then I'm going to walk away for a little bit and let you guys work it out. Uh, 243. Everybody needs a calculator out, right? We're going to need decimals. We all need calculators. Pretty sure this is 557. So we're going to use the quad formula with negative 0.6, 37.2, and negative 557. I put it in my calculator and I got it wrong the first time, guys. The first time I got it wrong. What does that mean? So make sure you're practicing this. You're gonna get on a test. I'm gonna give you decimals, and you're gonna get overwhelmed, and it's gonna be not enough time. So right now, put this in your calculator. You gotta practice it. Don't wait for me to put it in my calculator. Anyway, I looked at some websites that said that we're using marbles for energy and all the other kind of things. But our energy seems to be energy is clean, better for the air. However, nuclear energy does create like a really toxic poison. And we just kind of bury it in the ground, I think. It's a little dangerous. All of the energy sources have a danger involved. They're all risky. So each nation is kind of making its own decisions about what risks they want to take. The sons of the Middle East and maybe North Korea, we don't allow them, some countries, to make nuclear energy even if they want to, because they can make a nuclear weapon. So we monitor them. So the citizens in those countries get kind of mad because they want all of our nice electricity, but we don't even let them make some forms of electricity. But historically, that's what the conclusion came to. So a lot of our people in government are PhDs and these degrees where they've done a lot of studying on statistics and they know a lot of math. And when they're reading the research, they understand the numbers. So us as consumers, it's important for us to understand the numbers as well, so we can support them. Gotta look at this stuff. I don't want a PhD. Oh, it's like you get your 4-year college degree. You gotta do that. You gotta do that. And then you go and get a master's degree. That's like 1 or 2 more years. And then you go again 3 more years to get a PhD. Yeah, but they get paid more.
He says a master's degree if you don't go to 4-year college. Can you ask the 4-year college degree? Like, can you stop the master's? Or do you like if you're gonna be an accountant? Is that the only option?
No. Most of it would be
NTC is like a 2-year, right?
I think it's an accounting. That's what it is. Jake, you got a question?
Not anymore.
Okay. All right. All the people I know who have higher degrees are happy about it. And they're not mad about their student loans. They make them all. And there's a lot of news about it, but they're happy. They're happy they're making more money. How'd it go? Kevin, did you finish it? No. I didn't finish it either. Here I go. I'm gonna do the part under the article. Yeah, comes out to a decimal. Yes, let's just round to the 10th. And see how it goes. Last class I did 1,000, but okay. So I'm gonna do the discriminant first. The discriminant is the part under the radical bar. I'm gonna do that part first. 47. So you got 47.04 maybe. The if you were able to get to 47, you're using your calculator. What I'll do is now we gotta square root it. As soon as you round the number, you're supposed to switch to a square equal. That tells people looking at the math that you rounded. So I'm gonna switch to a square since I'm rounding these numbers. I'm putting down. So rounded. So we got plus or minus, and here's where our two answers come from. I'm going to split the equation. I'll do the negative 37.2 plus 6.9. And then I'll do it again, and I'll do the subtraction sign. Negative 37.2 minus 6.9. And it's 25.25 approximately. And it's 36.75 approximately. A lot of people are relying on my numbers, not clicking it themselves. Click it on your calculator. So what's the answer to the question? To 1980. That's the number of years since 1980. The nuclear power produced in the United States reached 800 million. So this is the T is years since 1980. So 1980 plus 25 would be 2005. So I'm going to say in the year 2005, U.S. exceeded 800 billion kilowatts produced. The second answer, 36, means it was that again, and that implies that it started going down, and I don't think it did. So mathematicians will come up with these models, and then they have to like redo them, recalculate them, because this is to say that it started at the y-intercept of 243, it hit 800, it went up, and then it started going down again. And I don't think it did. I think it's still going up. So they redo the math, they make a new model, and then they put that out there. And those are researchers that maybe energy plants hire, maybe fossil fuel plants hire, or maybe the government hires to find these numbers, keep track of our data. A lot of data analysts in the government behind all the things that we're doing. The media doesn't talk as much about the data as we could. All right, about yesterday's assignment and the discriminant. Did anybody have questions about that, putting it into big ideas math? You're putting your answers in again online today. Yes, what's your question? You didn't enter it in? So when you go to your Schoology, there's no ask button. Yeah, find ask Schoology. So you can go Schoology now. All right, have today's assignment written down. These are the book pages that you're gonna enter the answers in Big Ideas Math. What I like about that is that you're seeing if it's right or wrong. You're checking your answers, right? Check it and see if it's correct. The discriminant here, some people were square rooting it and entering it in Big Ideas Math and having it wrong. You put the number in before it's square rooted. That's the discriminant. It doesn't let you open it. But if we're in right now. Instead of going to the Schoology app, instead of going to Schoology,
The last thing that I did was the circle thing for something with a K.
Alright, here's our classwork. Yeah, instead of going to Schoology on your phone to enter in the answers, just Google and go to the actual website. Don't go to the app. Don't go to Schoology app. Go to the website. Oh, you circled the radio math. Yeah, I know it used to. I always had a hard time with it. Like just the ultimate Schoology math. This is Google. Okay. So anyway, we're on page 247. We're gonna read it. Here it is. Today we're starting systems. Now in algebra 1, you did systems. You graphed them. You saw where 2 lines crossed. And if they were parallel, they never crossed. They had no solution. So solving a system is finding where lines cross. So all of the functions can be made into systems. So today we're focusing on where a line crosses a parabola. Sometimes they never cross and there's no solution. Sometimes they touch just once. Like I think in geometry you guys talk about tangent lines where a line just touches. So sometimes it's like tangent to the parabola and sometimes it'll cross through in 2 places. Okay. I think tomorrow we'll do 2 quadratics and 2 parabolas. They can either never cross, touch in one place, or maybe they intersect in 2 places. So that's our goal today, is to solve systems. So here's an example of graphing a system. You graph the line, you graph the parabola, you see where it crosses. We're going to do number 4 on page 248. Find where these lines cross. So you got to graph both of these. You got to remember how to graph a quadratic. You have to use the axis of symmetry. Do negative b over 2a to find the axis of symmetry. How come you don't want to use a calculator?
Yes. Calculator is just it's not broken, just saying, like, when I compare a negative number. No, it's not that. It's not. When I square a negative number, I'm not negative.
Your calculator reads that like this. It's wrote it at order of operations, but it's doing this. So if you're telling your calculator to square -5, the negative has to go along with it. Spread the word. The biggest problem in this whole section is our calculator. Yes. Yeah, who just left though? Sylvia? Just wait till she comes in. Alright. So negative b over 2a, so that would be -4 over 2 times 1. 4 over 4, or 4 over 2 is 2. So we have an axis of symmetry at x equals 2. And then you remember how to make a graph. Take the 2, plug it back in to find the vertex. Go ahead, find your vertex. Plot your parabola. Four minus 8 minus 2, -4 minus 2 is -6. So this parabola has a vertex at 2, -6. There it is. Now, I want to do this quicker. This is too much. This is a lot of work, right? So I know this parabola is the parent function. There's no stretch or shrink on it. There's no a value. So this is congruent to the main parent quadratic function. So I know from here to graph, I can go over 1 up 1 and over 2 up 4 to make my graph. So there's the parabola graph. I could go 3, 9. 1, 2, 3. If you can't do it that way, just make a whole table. There's a parabola. All right, and now we need to remember how to graph a line. Y equals mx plus b. Y equals x minus 2. To graph this line, you have your y-intercepts. You begin at the b value, 0, -2. And then you move the slope, rise over run, up 1 over 1, up 1 over 1. And now that I've graphed both, I can see there are 2 solutions at 0, -2, and at 1, 2, 3, 4, 5, 1, 2, 3. And at 5, 3, points of intersection. I did that so much better this class than last class. It was all over the place in first period. I know I went through that kind of quickly. In your assignment today, you don't have to graph them. It's actually going to show you a picture, and you just have to say what points they cross. So I didn't make you graph by hand today, other than this example we're doing right now. I think we graph a lot more in our next section. So anyway. Oh, I'm putting that. You're talking about where did I put the 2? I put it back in the quadratic to find the vertex. I put it back in x squared minus 4x minus 6. Oh, that's what you're talking about or no? I'm just graphing this per hour. I'm ignoring that. So I plug this in to find that point. Because you do the axis of symmetry, you plug that in and find the vertex. Okay. Anyway, graphing is a lot of work. So if you scroll down now to example 3, same page, page 248. Mathing it out is actually going to be quicker than graphing. Which, if you look at all the steps, you might argue it. There's a lot of steps, right? But people actually do like this better than making a graph and finding where they cross. Making a graph is challenging. Also, most of the times a line and a parabola are going to graph at a decimal, so you don't see the answer anyway. So your real task today is to use substitution. So can you remember how to substitute? So when I look at this, in order to substitute, you need to have at least one variable alone. So here they had to subtract x from both sides to get y alone. You have to get y alone or x alone. After that, they were able to go back to the top equation, kick the y out, and plug in. So they plug in, simplify, factor it. It's a quadratic. Try factoring it. You get 2x values. You plug those in, get 2y values, and then you have 2 points of intersection. And really, while that looks like a lot, usually students appreciate it more than making the full graphs. So we're going to turn the page and do number 4 right now. No, I did number 8. Maybe we should do 9. Let's do 8 again. So we're on page 249. We're going to do number 8. We're going to substitute. So, if we were doing 7's actually easier. I would take this y out, and I would put this in, and I would have negative x squared plus 4 equals negative 4x plus 8, and I would solve that. 7's easier than 8, so that's why I'm doing 8 first, because I don't want to just do the easy one. So for 8, I'm going to get y alone. Subtract 2x from both sides. And y is negative 2x plus 5. Then I'm going to substitute in to the top equation. So I'm going to take this y out and put negative 2x plus 5 in. It does. It actually does. Combine my terms. And now we have a quadratic. You solve this anyway. Solve any way you can. I would try factoring what multiplies to 5 and adds to 1. 4 times 5 times 1. Can't factor it. If you can't factor something, what do? You could complete the square or just do the formula. Do the formula. Let's do it. If you can't factor, use quadratic formula. So the quadratic formula is just like one little step in this long You need to be comfortable with that. So I'll go to formula. A is 1, B is 1, C is 5. I'll let you just try it out too. Yeah. Man, I got negative 19. So what I do in here in the discriminant, I did 1. Yeah, 1 minus 20. All right, so this is imaginary. Our discriminant came out imaginary. So that means this system has no real solution. These lines don't cross. Okay, so that's an example of a line that's not crossing a parabola. I can show you, I put it in Desmos. This is what the graphs look like. They never cross. So. Sometimes they cross in one place, 2 places, sometimes never at all. Great, that's it. You guys have the rest of class to work on this. You have 3 math problems. You have 3 problems to practice this. The first 4 is 7 problems total. The first 4 is just looking at the picture and saying where they cross. So the first 4, the work is done for you. You're just saying what points they cross. The last 3 is doing that math we just did. So you have 3 real work problems. And you have to enter your answers on Big Ideas Math. So I will go make that live for you. Yeah. The example we just did. Yeah. And I have the work to show you for the first one. So just try to get into it. Here's the picture of that one if you want.